Hello, stat students. Last time we talked about in 6.2a um, random variables and transforming them. So, what would happen if we added or subtracted a constant, or if we multiplied a constant to a distribution to get a transform variable? This time, we're going to talk about combining two random variables. Combining random variables, adding and subtracting random variables. Let's investigate the result of adding and subtracting random variables. Let X equal the number of passengers on a randomly selected trip with Pete's Jeep Tours. Let Y equal the number of passengers on a randomly selected trip with Aaron's Adventures. So you see those two distributions. You have the light blue and then you have the orange. And underneath each one, you're given the mean of the distribution and the standard deviation of each distribution. And then there's a little blank spot for variance, and I'll get to that in a second. So, what do you think the mean of x plus y would be? Most people would just think that you would add those. So, this is what we're going to basically assume. So, the mean of x plus the mean of y is going to equal 3.75 plus 3.10, which is 6.85. What do you think the standard deviation of x plus y would be? Well, going along the same line, the standard deviation of x plus the standard deviation of y is equal to the 1.09 plus 0.943. That will give us a total of 2.033. All right. And then what do you think the variance of x plus y would be? Well, we haven't really touched a lot on variance, just barely touched on it in chapter 1, I believe. But variance is the standard deviation squared. So variance is the standard deviation squared. So we are going to take that 1.09, square it, and that'll give us 1.1881. And same over here, we're going to take 0.943, square it, and we will get 0.889249. And that'll complete that information. So what do you think our variance will be? Well, going along the same line, our variance of x plus the variance of y is equal to the 1.1881 plus that 0.889249, which would give us a total of 2.077, blah, 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 blah. All right, let's check to see if we are correct. So we are going to define t as our new distribution where we're adding x plus y. What are the mean and standard deviation of t? So this is a really long table, and then there's going to be a consolidated one. So I'm just going to tell you how the long table came about. So if we're going to add up, the top row would be the total number of passengers. So we would take 2 plus 2, and that'll give you 4 right here. And we multiply the probabilities because we're going to assume that they're independent. When you're assuming they're independent, you can multiply their probabilities. That the Pete's Jeep Tours has no effect on Aaron's Adventures. So that's where you get the 0.15 times the 0.3. And the next one, you're going to take 2 plus 2 from Pete's, add it to 3 from Aaron's, and then the next one's going to be 2 plus 4, 2 plus 5, and so on. And then you start with 3, and you go 3 plus 2, 3 plus 3, 3, and you do the whole thing. The reason why they're color coded is you have multiples of the same. So you have 5 passengers when you do the 2 plus 3, and then when you do the 3 plus 2. And so you basically add you multiply the probabilities to get each of the individual ones here, but then you add those to get this total right there. But basically, the last table is the nicer table because you have anywhere from 4 to 11 passengers, and then you have your total probability will add up to 1. So it's just a nicer looking table. The one before it just tells you where I got the bottom numbers. So the question we're asked is, what are the mean and standard deviation of t? So the mean ends up being, I mean, you can go ahead and do this. I did that. So you put this in list 1, put this in list 2, and then do the one variable stats, where list 2 is your frequency list, right? I'm going to keep saying that. And so I did that and I got the mean to be 6.85, which was the mean of what we thought it would be. So check. Okay, the standard deviation, when I did the one variable stats, was 1.44135 something, which is not the standard deviation that we thought because that was 2.033. The variance, so all you do with the variance is you take the standard deviation, which was at 1.44 something, square it, and you get 2.077, blah, 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 blah. And that was what we thought it would be. So the only thing that we didn't get right was the standard deviation. So standard deviations do not add like we thought. Can we add the means to get the mean of the sum? Yes. Can we add the standard deviations to get the standard deviation of the sum? No. But we can add the variances. And that will help us a little bit here in the next little portion. All right. The only way to determine the probability for any value of t is if x and y are independent random variables. And this is going to be a really big thing in all of second semester, and it is called the independence condition. Mark my words right here that it will be super duper duper important second semester. Okay. If knowing whether any event involving x alone has occurred tells us nothing about the occurrence of any event involving y alone and vice versa, then x and y are independent random variables. Probability models often assume, which is what we did in the very first part, and I said, assume that Pete's Jeep tours had nothing to do with Aaron's adventures. So probability models often assume independence when the random variables describe outcomes that appear unrelated to each other. You should always ask whether the assumption of independence seems reasonable. Because if you did all that work when you knew that they weren't independent, then that's not good at all. In our investigation, it is reasonable to assume X and Y are independent since the siblings operate their tours in different parts of the country. Now, I didn't tell you that, and we just found this out. I just said assumed that they were independent, but now that you know that they're in different parts of the country, one's not taking business away from the other, so they are truly independent. Okay. So for the rule, for the mean of the sum of random variables, for any two random variables, x and y, if t is equal to x plus y, then the expected value of t, and remember, expected value is just a fancy way of saying mean. So the mean of t is, and there's the capital E for expected, is equal to the mean of x plus the mean of y. In general, the mean of the sum of several random variables is the sum of their means. For the rule for the variance of the sum of random variables, when we add two independent random variables, their variances do add, as we noticed in the previous page, but the standard deviations did not add. For any two independent random variables, x and y, t is equal to x plus y, then the variance, variance VAR of t is equal to, so the variance of t is equal to the variance of x plus the variance of y. And since variance is standard deviation squared, so notice the symbol on the left side, that means the standard deviation squared, and that's for t, would be equal to the standard deviation squared of x plus the standard deviation squared of y. And this looks very familiar looking in a way. It's like the Pythagorean theorem, where you have a squared plus b squared equals c squared. So in this case, the standard deviation of x squared plus standard deviation of y squared equals standard deviation of t squared. So if you want to solve for, in the Pythagorean theorem, if you wanted to solve for c, you took the square root of both sides, and that's what you do. You take the square root of both sides, so the square root of, I'm sorry, not the square root, so the square root of um, the standard deviation of t squared is just equal to the standard deviation of t. And then the right side would just be the square root of the standard deviation of x squared plus the standard deviation of y squared. And so that's how they're related. So you have those, you can use this formula if you're given the variance and standard deviation, or you can use this one. It's totally up to you. In general, the variance of the sum of several independent random variables is the sum of their variances. So for the mean and the variances, they do add. The standard deviations don't add. That's what we've discovered so far. Now, going to our example, back to the El Dorado Community College, in the top row, those are the number of credits a full-time student is taking at the college, the number of units X that a randomly selected El Dorado Community College full-time student is taking in the fall semester has the following distribution. We've done this earlier, but the mean of the distribution is 14.65 units. The variance is 4.23 units squared, and the standard deviation is 2.06 units. Right. El Dorado Community College also has a campus downtown specializing in just a few fields of study. Full-time students at the downtown campus only take 3-unit classes. So they could have 12 units, 15, 18. They can't have the 13 or 16 or 17. Let y equal the number of units taken in the fall semester by a randomly selected full-time student at the downtown campus. Here is the probability distribution of y. So top row is the number of units, 12, 15, 18, and the bottom is the probability. Notice they add up to 1. The mean of that particular distribution is 15 units, the variance 5.4, and the standard deviation 2.3. Right. If you were to randomly select one full-time student from the main campus and one full-time student from the downtown campus and add their number of units, the expected value, so mean, of the sum would be, so the mean of their sum, so x plus y, would be equal to the mean of x plus the mean of y. So that would be 14.65, and that's why I circled everything, plus 15. So that would be 29.65 units. Make sure you put your units when you're doing these problems. Some of you did not on your homework, and I mention it. I'm not taking off now. That's why I mention it while you're doing your homework when you're practicing. Okay, and so the standard deviation of the sum, you could do it 2 different ways. So I'll show you both ways. So the standard deviation, if you were to use, because the variance is given and the standard deviation is given, so you can do either one. You can do the variance of x plus y. So the variance, oops, hold on. Right, so the variance is equal to the square root of the standard deviation squared. So you can do it this way. Variance of x plus variance of y and then the square root of it. So the variance of x was 4.23, the top one, plus y is plus the variance of y is 2 point or 5.4, sorry. You add that, you get 9.63. You take the square root and you get 3.103, and that is the variance of x plus y. Right. Should have been just units, not squared units. So I don't know why I put squared units up there. So just ignore that. And then you can also do, oh, that's because it's standard deviation. Sorry. Or you can do it this way. The standard deviation of x plus y. Notice you can't just add the standard deviation of x, but you can go back to like what looked like your Pythagorean theorem. So that's the square root of the standard deviation of x squared plus the standard deviation of y squared. So it's the same thing. So it'd be 2.06 squared, which gives us that 4.23, plus 2.3 squared, which would give us that 5.4. And that gives us, well, not exactly 5.4, and I'll show you why. If you add those, you get 9.5336, which gives us a total of 3.088 units, and that's the standard deviation of x plus y. So notice the answers. One's 3.103, the other's 3.088. However, if you look at all the information that was given, that's due to rounding error. And if you show your work, either of these is acceptable. But the main thing is you must show your work. So it's okay that you have a little bit of an error. As long as you show your work and your process, then you're okay. To You can't really eliminate rounding error, but you can minimize rounding error by having the most digits possible so that you're as close to, you're as accurate as you can be. All right. Another sample. Well, I guess this is the same El Dorado one, but just a different thing added to it. Let B be the amount spent on books in the fall semester for a randomly selected full time student at El Dorado Community College. Suppose that the mean of the book cost is 153. Here I am talking about um, units and me leaving it off. And the standard deviation is 32, but that's okay. We'll put in our answer. Recall from earlier that C equal overall cost for tuition and fees for a randomly selected full-time student at El Dorado Community College. Um, the mean of the cost for tuition fees was $832.50. This was from 6.1a, and the standard deviation of the overall cost was 103. Here's our problem. Find the mean and standard deviation of the cost of tuition, fees, and books. So we're going to combine those two distributions with the overall cost and the cost for books. So the total cost, so the mean of the overall cost that includes the cost of tuition and fees plus the books is equal to the mean of C plus the mean of B. So 832.50 plus 153. And so that is $985.50. This isn't really too bad. As long as you do a lot of practice problems, you're good to go here. The standard deviation of the overall cost plus the books is equal to, this time the variance is not given to us, so we're going to use our standard deviations and we're going to square them. And it doesn't matter which order you put them in because we're squaring them. So 103 squared plus 32 squared, and that is 11,633. And then the square root of that would be $107.86. So that's the standard deviation of the overall cost with the books. So there you go for that. Okay, so we've talked about adding two distributions. What happens when you're asked to find the mean of the difference of random variables. So for any two random variables, x and y, if d is equal to x minus y, then the expected value of d, so the expected mean, is equal to the mean of x minus the mean of y. So it follows the same rule as adding, but this time you're subtracting. So in general, the mean of the difference of several random variables is the difference of their means. However, the order is really important. So the order does matter in the finding the difference. So make sure you pay attention to what it's asking you to do. Okay, as far as the variance of the difference of random variables, for any two independent random variables, x and y, if d equals x minus y, then the variance is still going to be the same. So the variance of x, so the variance of d is equal to the variance of x plus the variance of y. So they add just like they did before. And since variance is standard deviation squared, the standard deviation squared d is equal to the standard deviation squared of x plus the standard deviation squared of y. So we can find standard deviation by taking the square root. And none of these formulas are on your formula sheet, so you're basically expected to know this. There you go. So you're not going to subtract standard deviations or any of that stuff. In general, the variance of the difference of two independent random variables is the sum of their variances. Okay, going back to another problem. The mean of the main campus credits, T, is 14.65 units. The variance is 4.23 units squared, and the standard deviation is 2.06 units. The mean of the downtown, it's not supposed to be campus tuition, it's supposed to be credits. So let's fix that. Is 15 units, variance is 5.4 units squared, and the standard deviation is 2.3 units. Suppose we randomly select one full-time student from each of the two campuses. What are the mean and standard deviation of the difference in tuition credits, not charges? So here, notice this order matters. It's T minus U. And so T being the main campus minus the downtown campus credits. Interpret each of these values. First, let's find the values. So the mean difference is equal to the mean of T minus the mean of U. So the mean of T is 14.65 minus 15. It's okay to have a negative answer. So the mean difference is equal to negative 0.35 units. We'll interpret that in a second. Let's just go ahead and find the standard deviation. Of course, a lot of times you'll lose points on a test because students overlook this portion here when it's asking you to do something else. So many times my students have missed points on a quiz because they'll forget that portion of the problem. Okay, so for the standard deviation, and we could use either one. So standard deviation of D is equal to, I find it easier to use this one. What is that? Okay, so the standard deviation squared of T was 4.23 and of U is 5.4. And then you add those and take the square root of them and you get 3.103. And so the interpretation is always the hardest part. So let's interpret the negative 0.35. The average credit difference between, remember it was T minus U. So T was the main campus. So between the main campus, so how you word this is super important. It would be wrong if you said the average credit difference between the downtown campus and. So between the main campus and the downtown campus, is negative 0.35 credits. Right. For the standard deviation, the interpretation, on average, so remember, standard deviation is how far something is from the mean. So on average, the difference in credits, getting lazy, so I'm starting to abbreviate, between the two campuses. I'll keep saying this over and over again. I write so much in this class. I get writer's cramp here. Will vary. So those are the words there. Will vary from the mean by about 3.103 credits. Right. Hopefully this hasn't been, there's a lot of information in this chapter, and so much of it is left off your formula sheet. So a lot of it you just need to study and do a lot of example problems so you do really well on them. Okay, now since we can since we can find the means and standard deviations, we can do normal CDF if we're combining normal distributions. So this is our last topic. If a random variable is normally distributed, we can use its mean and standard deviation to compute probabilities. An important fact about normal random variables is that sum or difference of two independent normal random variables is also normally distributed. Here's a sample example. Mr. Starnes likes between 8.5 and 9 grams of sugar in his hot tea. Mr. Starnes is one of the authors of the textbook, and I met him, and he's super nice. Suppose the amount of sugar in a randomly selected packet follows a normal distribution with mean 2.17 grams and a standard deviation of 0.08 grams. If Mr. Starnes selects 4 packets at random, what is the probability that his tea will taste right? So we are going to assume that the amount of sugar in one packet doesn't affect the amount of sugar in another packet. So we are going to assume that they're independent random variables. And in that valid assumption, then we can go ahead and continue our problem. So the mean of, I'm going to put 4 packets here. So the mean of 4 packets, you would just add each individual mean for the packet. So 2.17 plus 2.17 plus 2.17 plus 2.17. And that gives us the mean of 4 packets as 8.68 grams. And remember, we haven't even calculated a probability. We're leading up to it. So that's our mean. And now for our standard deviation, the standard deviation of 4 packets is equal to the square root of the standard deviation of the first packet, so 0.08 squared, second, third, fourth. Do all the math, and you get the standard deviation of 4 packets is equal to 0.16 grams. Now we need this and we need that in order to calculate our probability. So now we can use our normal CDF and our lower bound is because he likes between 8.5 and 9 grams of sugar. So there's our little interval. So our lower bound is our left bound, 8.5 grams. So that's lower bound. Upper bound is 9. Hopefully your notes and you're labeling these. If you label in your notes, you're apt to label it on tests, free response questions, right? And then your mean is 8.68. We just found that. and our standard deviation is 0.16. Put that in your calculator. Again, remember your best friend doing normal CDF is second VARS. Just keep on practicing, keep on doing it, and you will be a master. That ends up equaling 0.8470. So that's an 85%, I'm just rounding it, chance that his tea will taste right. Right, one last example for the day. Suppose that the height M of male speed daters follows the normal distribution with a mean of 70 inches and a standard deviation of 3.5 inches. And the height F of female speed daters follows a normal distribution with a mean of 65 inches and a standard deviation of 3 inches. What is the probability that a randomly selected male speed dater is taller than the randomly selected female speed dater with whom he is paired? So this is super duper important and how it was worded. So the male's height has to be bigger than the female's height. So in order to write that accordingly, the male height has to be bigger than the female height. And we are going to move everything to one side and then set it to greater than 0. So what we're going to do is we're going to subtract f on both sides. And so we have m minus f is greater than 0. We want the difference to be greater than 0. We're going to use this here in a second. So keep that in mind. Now let's find the means and standard deviation. So the mean, male minus female, is equal to, okay, so the male mean was 70 inches minus the female was 65, so that's 5 inches. The standard deviation, m minus f, is equal to 3.5 squared plus 3 squared, which gives us 21.25, which gives us 4.61 inches. Okay, so we have our two important pieces of information we need to do our normal CDF. So for our normal CDF, our lower bound is going to be this 0 right here. So the difference is going to be 0, and our upper bound is going to be a really large number. So I'm going to run out of room, so I'm just going to put LB. Upper bound, let's say 100 or 1,000. Our mean is 5, and our standard deviation is 4.61. Always in that order, mean first and standard deviation. And that gives us a grand total of 0.861, which means 86% chance that a male speed dater is taller than the female. And now I'm going to rest my hands so I don't have to write anymore. And that is all the notes for today. Have a great day, stat students.